Welcome to this video on AWS Auto Scaling, where your application grows without manual intervention. Traditional infrastructure often fails under demand spikes, forcing a trade-off between overpaying for idle capacity and crashing under peak load. AWS Auto Scaling eliminates this, adjusting capacity in real time automatically. This program is Module 5, Episode 2 of the AWS and Cloud Foundation series, brought to you by the Series of Thoughts team. Imagine your site gets a 10x traffic spike overnight. With fixed servers, your site crashes and you lose customers. With autoscaling, AWS adds capacity to handle the load and scales back down when it's over, resulting in sales, not support tickets. Autoscaling prepares your infrastructure for inevitable traffic spikes. The fundamental problem with fixed capacity is the painful choice between over-provisioning and under-provisioning. Over-provisioning means paying for idle servers. Under-provisioning saves money, but results in crashes during critical peaks, like launches or seasonal spikes. Autoscaling eliminates this trade-off entirely. It matches capacity to demand, scaling up and down automatically. You pay only for what you use, avoiding costs for idle capacity. This means you never miss a customer, as new capacity comes online in minutes, ensuring a responsive experience regardless of load. Chapter 1 covers EC2 autoscaling groups, the foundational building block. An autoscaling group is a logical collection of EC2 instances managed together, with defined boundaries for how small or large the group can grow. Your scaling group is defined by three numbers: minimum, desired, and maximum. Minimum is the floor for your availability guarantee. Desired is the current capacity autoscaling aims for. Maximum is the cost protection cap the group will never exceed. Scaling groups respond to demand in a cycle. Starting at a baseline capacity, traffic increases trigger a scale-out, adding instances. At peak, maximum capacity handles the load. When traffic drops, scale-in terminates excess instances. The service continuously adjusts capacity to meet demand within minutes. Chapter 2 focuses on scaling policies, the rules that teach AWS when to act. Policies tell the autoscaling group when to add or remove capacity, and by how much. AWS offers three distinct policy types, each suited to different operational needs. Target tracking is the autopilot policy. It works by setting a target value for a metric, like 60% CPU utilization. AWS continuously adjusts instances to maintain this target. It's best for web apps, APIs concerned with latency, and workloads requiring zero configuration management. Step scaling provides a graduated response to pressure based on the severity of the metric breach. Small pressure yields a small response, while large pressure gets a larger one. Examples include adding 2 instances for moderate load, 4 for high load, and 8 for critical load to prevent outage. Scheduled scaling is for when you know what's coming, allowing you to pre-position capacity before demand arrives. This is useful for predictable traffic, like a weekly product update surge, month-end billing runs, or seasonal peaks such as Black Friday and Cyber Monday. When choosing the right scaling policy, target tracking handles variable loads automatically. Step scaling uses known thresholds for graduated, more controlled responses. Scheduled scaling manages predictable, calendar-based patterns. Many production workloads use a combination of scheduled scaling and target tracking. Chapter 3 covers launch templates, the blueprint for every new instance. When autoscaling needs to add capacity, launch templates provide the complete and consistent configuration blueprint for exactly what to create. A launch template defines several key items. It specifies the AMI, or Amazon Machine Image, for a known good starting state. It determines the instance type, matching hardware specs to your workload. It also includes the security group and IAM role for security posture, as well as the key pair and user data for automatic bootstrapping. Launch templates are the clear choice over older launch configurations. Templates offer versioning support, native spot instance mixing, and the ability to specify multiple instance types. Launch templates are the preferred AWS recommendation, as new EC2 features will only be available through them going forward. Chapter 4 covers elastic load balancing plus autoscaling, built to work together. Autoscaling and elastic load balancing are two separate services that become dramatically more powerful when paired. Neither is complete without the other for production workloads. Autoscaling manages capacity by adding and removing EC2 instances, ensuring the right number are healthy. Elastic load balancing, specifically the ALB, distributes incoming requests across all healthy instances. Together, they provide seamless and automatic capacity management. During a traffic spike, user requests hit the load balancer and are distributed. As CPU rises, autoscaling launches new instances. These instances register with the load balancer and begin receiving traffic once they pass health checks. Connection draining ensures graceful scale-in. When autoscaling decides to terminate an instance, connection draining allows in-flight requests to complete. The ALB stops routing new requests to the instance, and it is cleanly terminated once existing connections drain or the timeout expires. Chapter 5 is about self-healing infrastructure. Autoscaling monitors the health of every instance and replaces unhealthy ones automatically. This allows infrastructure to heal itself without needing to page anyone at 3 a.m. Health checks utilize two complementary channels. EC2 status checks monitor the underlying hardware and OS. ELB health checks ensure the application is returning a healthy response, catching application-level failures. Both are used for comprehensive coverage. The automatic replacement loop begins when an instance fails a health check. It is marked unhealthy and removed from the load balancer. The unhealthy instance is then terminated, and a new replacement instance is launched to restore desired capacity. Chapter 6 covers application autoscaling, which extends capacity management beyond EC2. Modern architectures often include containers, serverless functions, and managed databases, and application autoscaling extends the same principles to these services. Application autoscaling covers services such as ECS, allowing you to scale container tasks based on metrics. It manages Lambda-provisioned concurrency to eliminate cold starts. It scales read and write capacity for DynamoDB tables and adds or removes Aurora read replicas based on query load. Application autoscaling uses the same consistent scaling model across services. It utilizes the identical target tracking, step scaling, and scheduled scaling policy types. Scaling decisions are driven by CloudWatch metrics, and events are recorded in a unified activity log. Chapter 7 focuses on cost discipline with autoscaling. Autoscaling is a cost optimization tool as much as an availability tool. Used correctly, it actively drives down your AWS bill while improving reliability, but it requires intentional configuration. 3 key levers control cost. Setting a maximum instance limit creates a cost ceiling. Using spot instances for scale-out capacity leverages significant discounts. Monitoring scaling events in CloudWatch helps you catch unexpected behavior and misconfiguration. The mixed fleet strategy combines on-demand and spot instances. On-demand instances form the reliable baseline for sustained load. Spot instances handle scale-out capacity at up to a 90% discount, making peak traffic management much more cost-effective. The real cost of not using autoscaling is often high. Traditional provision servers run at only about 30% utilization, meaning 70% of capacity is paid for but unused. Autoscaling with spot instances provides substantial savings and requires zero ongoing manual effort once configured. Next, we will walk through a practical demo on building an autoscaling group step by step. This walkthrough will cover configuring an autoscaling group behind an application load balancer, the most common production pattern for web applications on AWS. The demo configuration starts with a launch template, defining the AMI, instance type, security group, and a user data script to install the application. Next, we create the autoscaling group, setting minimum, desired, and maximum capacity, and linking it to the ALB target group across multiple availability zones. We then attach a target tracking policy, aiming for 50% average CPU utilization, which automatically creates the necessary CloudWatch alarms. Finally, we simulate load using the AWS load testing tool and observe the scale-out and scale-in activities in the autoscaling activity log. The activity log provides an audit trail of scaling decisions. A scale-out entry shows an instance launched because the average CPU exceeded the 50% target. A scale-in entry shows an instance terminated because the average CPU fell below the target. A health check entry shows a failed instance being replaced. Before building, consider 5 key decisions: your application's statelessness, AMI strategy, capacity sizing, policy selection, and cost modeling. Working through these decisions will minimize rework and ensure optimal scaling behavior. The business takeaway is that autoscaling stops you from losing customers to insufficient capacity and stops you from paying for capacity you don't need. It's a clear example of the cloud's advantage over traditional hosting and requires zero ongoing management once configured. Autoscaling provides a complete picture across 4 pillars. EC2, autoscaling groups define capacity. Load balancer integration ensures traffic distribution. Self-healing replaces unhealthy instances. And cost discipline optimizes spending through maximum limits and spot instances. For a structured approach to scaling, use the free Scaling Readiness Guide. This one-page framework helps you check statelessness, define your AMI strategy, size capacity, select policies, and estimate costs before building your first autoscaling group.